Resuming work on this, what I think to be an early 65 AC50. See the previous video, link in the description. You'll see what a sad state it was in. It was all bent at weird angles and flopping around and all kinds of damage to the little bends and nicks on this front panel. So I've done an awful lot of work to get it to this point, involving removing everything off the top. The pots still aren't back. Taking the panel off, cleaning the back of the panel, cleaning the front of the panel, cleaning the chassis, and putting the chassis into a series of clamps and clamps with some padding for the panel to get all the little divots. Like here, there used to be a big bend. It's all pressed flat again. And this will be held in place rigidly when the pots are there. The ends have some double-sided tape to help them hold down, especially here where there's nothing in this area clamping down. But you'll see that it is overall much better. Now, you'll also see this block of aluminum. What's this doing? Well, the chassis was really warped in this area, and one of the reasons it was really warped was there would have been a spacer between this tab of the transformer and the chassis originally, and that was long gone, and someone had it clamped in without the spacer. So notice the gap down here at the bottom between this steel and the aluminum section of the chassis. So there's about an eighth of an inch gap there, but at the top, and then this plane's on this plane, not this plane, so even more of a gap is supposed to be there. But they just clamped it, and when they clamped it, this entire piece of aluminum on both ends just bent. Zoop. So to make up that space, I went and bought some aluminum bar stock, about an inch and a half wide, about an eighth of an inch deep. I mean, it's metric, but I'm giving you the U.S. equivalents. And it was 4 feet long. I cut off a section about 4 inches, whatever this width from here to here is. I measured it just about 4 inches. Gave myself an eighth of an inch at either end for some additional rigidity, and cut it and filed off the cut marks, and I drilled where the holes needed to be. And so you've got a new stainless screw with a compression washer, and then a large washer, stainless steel, another fairly large fender washer here, then the bar stock, and that made that gap correct. And then on the inside, a big fender washer, and then a stainless nylock nut. Same thing for here. So this part of the chassis is really reinforced with all this surface area of the steel washers compressing against this aluminum bar. Same thing for the one you can't really see here. And the same thing, minus the aluminum bar stock at the other end, where I still had to make up a little bit of a gap, but much less so. So it's got large washers on this side, large washers on this side, and this one, this little flange off the transformer had been broken in the past. Instead of being a tab with a hole in it, it had been formed into like a C. It was open on this space. So I used two double washers here, a little bit larger surface area. So it's really hitting about 3/4 of this tab. The other one's entirely being hit. This is much more up to the task. This was a lot of work, getting everything taken apart and cleaned. I mean, it still looks, the chassis still has some corrosion from the decades, but it's clean now. Getting the tube sockets all cleaned out. All right, you'll see this on Voxes, you'll see this on Marshalls, you see this on other style amps, where they have this dress nut with the 2 slots. And if you get in there and try to tighten it with just one at one end, you're going to make a big mess. You're going to slip off and scratch your panel. If you try to do 2 screwdrivers at the same time from opposite sides, good luck. If you slip, you're going to damage things. The solution is to have a proper spanner wrench. Now, this one's sold as a lens spanner wrench. I'll also use it if I need to service a lens. But it's an adjustable gap, and you can buy them with different size ends. This one works for this. I've already adjusted it to go here to fit in these 2 slots. And then as long as I'm very careful and keep them in the slots and I hold the other side, it tightens up and didn't slip off and scar the panel. Let me see if I can get it a little bit tighter than that. These are slightly on the small side for this. I need to buy some other larger tips to really get it perfect in case one was ever really stubborn, but this one was okay. I had already applied a little bit of 3-in-1 oil before I took it off, and then I cleaned all the surfaces. So this was sufficient, but they do sell slightly larger ones. So do as I say more than as I do. I will get another set that are larger, but this is what I had, and this was better than trying to do it with any other tool that is commonly found on a tool shelf. You'll notice the pots aren't in place yet. This one was a non-standard size replacement a long time ago, and this one is missing a shaft. Why is this one missing a shaft, you say? Well, actually, the shaft isn't missing. It's right here, sitting on the desk. Of the 6 original Bulgin knobs, 3 were missing their set screws, the grub screws. It's a British thread, BA grub screw. And rather than find the correct replacement grub screws or put on a replacement knob, some previous genius decided to use super glue to hold them in place. So 3 of these were super glued in place. And on 3 of them, I could loosen the super glue by carefully turning and lifting at the same time and breaking the seal and getting enough of the shaft exposed so that I could heat it with the soldering iron and then slide this off, because the material of the shaft and the brass insert heat at different rates, so I could separate them. But on this one, as I tried to lift and twist to break the super glue seal, instead of the seal breaking off of the knob because of all the super glue, it broke inside the pot. So this pot and this pot are getting replaced. And since there are only 6 pots in the entire amp, and pots are inexpensive, I've ordered 6. So in case any of these old pots are defective, we won't delay the repair. But the owner will only pay for the pots to end up going in the amp. And I'm sorry about this. This is why you should never use super glue to hold a knob on. People, don't do it. Grr, arr. But in happier news, the inside is looking really pretty. Every single one of the old Erie or Hunts resistors in the amp had drifted by crazy amounts. Now that may sound like hyperbole, but if you've worked on a bunch of old Voxes, you know that these things were junk. The resistors just don't last. Something that's supposed to be 100K may measure 180K. I'm not talking about within 20% tolerances. I'm talking about no longer the correct circuit in the slightest. Not a cool variation on the original circuit, just not how it's designed to operate. And 10 years ago, I could have had 1-watt carbon films for the entire thing. But there are fewer 1-watt carbon film axials made. And I called the owner and said, look, we can sort out old replacement 1-watt carbon comps if you want. It'll cost a lot of money, take a bit of time to get all the parts we need, but we can do that. Or I can populate it all with 1-watt carbon films from various manufacturers, and they would cosmetically be a little bit different from each other. Or I can replace them all with half-watts from the same series if they all cosmetically match. And AC30s had half-watts, and this circuit is no different. And Marshall 50 watts have half-watts. This circuit is no different. There's absolutely no reason to use the 1 watts over the half-watts, and he chose to go with the half-watts. So these are all half-watt carbon film 5% Diageos. Aside from the Vishés that I'm using as droppers, these are some 10Ks. The 22K 2 watts are on order, but the 2-watt 10Ks are in place. You can see one lone little Pyre 470K. That's a mixed resistor. That'll get addressed once I know that the pots are good, because it's other 470K mixed resistors going from this point on the board to one of the pots. And I don't want to replace that until I know the exact span or if it's necessary. All the film caps are original, the Phillips mustards, and they seem to be fine. Hopefully they all are fine. They measure fine, as much as I can measure them in circuit. And the old picofarad value cap there, I think is a Lemco, seems to be fine, and everything cleaned up very nicely, which is nice. What was not as nice was a mistake made possibly back in '77 when some work was done on this amp, when a tech replaced one value part with the incorrect value. Now, the output of this model AC50, early 65, has a paraphase phase inverter. And in a nutshell, how that works is one of the output caps feeds its signal to one of the tubes, the output tubes, as normal, but it also goes through a pair of resistors forming a voltage divider. And at the voltage divider point, it feeds the other grid of the 12AX7 used for the phase inverter, and then that feeds the other output coupling cap. So you take the signal, you amplify it, you send it to one side of the tubes, you also decrease its level, you feed it to the other side of the tube, and then it gets amplified and sent out the other side. In theory, the same signal. It never quite is, but in theory, the same signal, just inverted. And in the AC50 schematic, and in every copy of the AC50 schematic I found, including the one that JMI published, they had 470K resistors for that dropping stage. There's one there. I think the other one's right there. I'm behind the camera right now. But the tech had used 47K. Now, 47K will work in terms of you get to 47Ks, you will get a voltage divider. But in terms of the impedance, you've gone from 940K resistance to 94K resistance. So the impedance, the load on that is way crazy high. So the output of this side of the phase inverter would not have been working very well. It would have been very inefficient with a 94K load. And 94K as a R after a C means your high pass jumps way crazy high compared to an almost completely flat phase inverter output as far as the high pass goes. So 47K is not a suitable substitute for 470K in this circuit. It is a very common mistake. Everyone who has worked on amps has made that mistake. Oh, I thought it was an 82K, it was an 820. Oh, I thought it was a 47K, it was a 470K. But you have to check your work. Listen to the amp after it's done. This amp never would have sounded healthy if that all work was done in 77 and all these parts were new at the time and you play it. This would have sounded, for lack of a better term, wonky, wrong, not right. Anyway, 470K, everything else per spec. And you can see throughout, I've got the 63 volt, 22 microfarad Vishays that I love for the cathode bypass stuff. And it doesn't really matter electrically, but it matters to me as a point of pride and a point, if I'm paying attention to this kind of detail, I'm less likely to miss anything that is crucial. All the resistor tolerance bands are on the same end. All the resistors are the same length, attached mechanically before soldered. All the capacitors are going to the outer side with a little bit of a mechanical hook, and everything's neat and no excess, but nothing is skimped, nothing is solder starved. And you make yourself do the cosmetic thing, which takes care of the actually important stuff at the same time, because you've got to do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24 resistors just on this one board. And if you get impatient and you start hurrying up, you will make a mistake. Not you, I'll make a mistake. We'll all make a mistake if our goal is to get it done as fast as possible. But by just saying, okay, I know what this distance is, I'm going to use my bender to get them all there. I'm going to make this height above on each one of them 1/4 inch, or this one on each 3/8 of an inch. You get that consistency to your flow. And you know that this is spaced evenly, and they're all the same height, all the resistors and all the caps are the same height. And you know that you're going to have just enough excess to do your mechanical connection before you solder it. It's kind of a Zen thing, not to get philosophical, but it really does matter to the end result. Now, the other end of the chassis looks almost perfect, 90 degrees, 90 degrees. This one doesn't look as perfect because the bend was really dramatic in this area. And there's only so much I can do without taking the amp completely apart, which is really not worth it, because a lot of the wires from the transformers have wax coatings, and they have to be where they are. It was how it was built in 65, and if I disturb all that, the wire will break off in chunks. I don't want to start melting beeswax into this thing just for the sake of that. I have got this infinitely better than it was, Everything is reinforced. There's a washer here over this flange. There's a washer. There are two washers on this side. So while it has been bent back very close to perfect, I can't get it perfectly. And in every area where the chassis experienced the bends, I have reinforced it so that it's very unlikely to happen again in the future unless this amp were just dropped, 12 feet off a loading dock, in which case, good luck to you. There's only so much I can do. But I'm very pleased with how this came out. This will sit in the chassis, the cabinet very well. You won't have huge gaps. And just getting all the dents and warps out of this faceplate makes a huge difference. Before I show you the output section, real quick, on the output here, they had a 3-watt 470 ohm resistor. I've replaced it with a 5-watt. And I also cleaned up the solder joints in this area where all 2 wires on this side of the output transformer and 2 wires from this side of the output transformer and this wire and the leads all went in here. They've all been soldered together before they go in here, so they're not just relying on these screws to make a connection. That makes it much more reliable in the long run. Here in the output section, seemingly less has been done, though a lot of stuff has been removed. I don't know too many techs that stock 450 volt 4 microfarad caps, so those are in order. On that note, in the first video, I had mentioned that I wasn't sure how easily I'd be able to get a replacement for this dual 16450. So 2 positives and 1 negative. And as many people helpfully pointed out, F&T does in fact make this value. It was just in a different section of my vendor's site, but I did find them and they are in order and they're even the correct diameters. So thanks to everyone for helping me out. I can't pretend to know everything. I guess I could pretend to, but I cannot know everything. So thank you for having my back, guys. But yeah, those are on the way. I mentioned that the old resistors in the amp were wildly out of tolerance. So they're almost all getting replaced. I think they're all getting replaced, unless you count a potentiometer as a resistor. So these 220Ks that are grid leaks, the bias leaks on the output grids, were crazy out of spec. So they've got some 2-watt Vichy metal films. Nice, rigid, strong leads. They're not going to bend and get out of the, get moved and touch things they should not. The actual grid stoppers, I went with the 1Ks. I may revisit that value. 1K seems a little underwhelming for EL34. If I get any weird oscillation or blocking, I may bump these up. A Marshall with EL34s usually have 5.6Ks. I would expect to want to use something closer to 2 to 5K. Not 1K, but we'll start with the original value. In stock form, the screen grids had individual 100 ohm half watts. They've been replaced with these 5-watt 470 ohms. And they both shared one big screen grid resistor, which was a 3-watt 750, which was this noble beast that sacrificed itself. I have replaced that with a 5-watt 1K. So 1K versus 750, so 1,000 versus 750, and then 470 versus 100, and 5-watt, 5-watt, 5-watt versus 3-watt, half watt. This is less likely to ever go up in smoke. If it does, it's nicely elevated, won't burn the board or the wires surrounding it. These are giving much more protection to the grids than this original circuit. And this is going to be very, very reliable. In the original amp, they had these 2-watt 47 ohms to ground from each cathode to ground. And the previous tech had jumpered this side and jumpered across to ground. So there was no resistance between the cathode and ground in this amp. Many people will install a 1-watt from cathode to ground with EL34s just to measure bias. The original circuit had 47 ohm. I've got some 5-watt versus these 2-watt or 3-watt 47 ohms that'll go here, and I'll have them in place and replicate that. And if I'm not pleased with the behavior of the output section with that increased resistance between cathode and ground, I will replace them with some 1 ohms just for measuring the bias, because it's convenient and it looks better than just doing a jumper like the previous tech had. I understand why they did it though. These 33Ks and this 12K I just didn't have in stock, so I've got some 2-watt metal films on order that, just like these 220Ks here, these are voltage droppers, bleeders across the caps that'll go here. These are where the 4 microfarad 450 volt caps go. And again, I don't stock that. As far as these diodes go, they measure okay. They're old Mullards, and it's always cool to have something that says Mullard in your app. So unless I hear noise or buzz because one of them is not working as well as possible, they can stay. I do have some 1N5408s, and I've got 1N4007s, either of which will work just fine in here. But these bell-shaped Mullards are pretty, and they measure okay so far, and I haven't heard them, obviously. Sometimes you'll have a diode in a rectifier that measures fine, but just makes a buzz. So hopefully they can make it. If not, I've got some suitable replacements. This is a non-original cap, this orange drop, but it is a high-quality cap and a good cap choice for the job. It's rated for 1600 volts DC, and so this just had a layer of grease and dirt on it, and it cleaned up very nicely, don't you think? Much prettier. I'm not too thrilled with some of the solder joints there. I'll probably remove all the old solder and redo that just to be a little bit more sure. Now, on the schematic, the 65 AC50 would have had a bribe after the solid-state rectifier, and this does not seem to have one or to have had one. It would not have been in this space. It would have been from here to the main filter cap. But it's also possible that this one is early 65 and never had the bribe. So, and unless I see proof otherwise, I'm going to think this amp never had the bribe. But it's possible that it did. It failed, and a wire was rerouted. That's not reflected in this situation. I'm just not sure. But it's possible that it was from here to here, and that they've since jumpered this. It's always fun playing sleuth. The amp does not need a bribe. I'm just saying that later 65 AC50s did have it. If any UK techs who've worked on a whole bunch of AC50s can chime in on that bribe thing, I would appreciate it. I imagine you see more of these than we do in the States, though not many of these were ever made in the grand scheme of things. Here you can see how the lead dress from this power transformer is very neat and very specific, and it's just absolutely coated in wax. So if I were to disturb all this to remove the transformer to try to get out this curve in the chassis here, I would do more harm than good, which is why I've gotten the chassis vastly improved, but I'm not trying to make it look brand new. This would be, I could replicate all this. I could disconnect all this and use a hairdryer to get all the old wax off, put it back where it needs to be, and then carefully drip paraffin or beeswax back where it used to be. But the owner would pay an awful lot for a few cosmetic tweaks in the end. It would just be an awful lot of labor to try to play time traveler and not in a meaningful sonic or reliability way. So I'm not particularly interested in doing that. Someone in the comments of the first video asked what I was going to do about the heater hum in this amp. Now, I've not heard this particular amp yet. I don't know whether this amp will have any heater hum. I know that either this white wire or this brown wire is the filament center tap. And if it is noisy as is, I can disconnect the physical center tap from this ground point, which goes to chassis, just to the left of what you see on screen. And I can then put in an artificial center tap if that helps. Or I could, if necessary, create about a 50 to 70 volt DC node within the amp and reference the artificial center tap to that elevated DC. So those are my options to remove any heater hum, though I don't know whether either or any of those methods would be appropriate or necessary, but I'm not sure yet which of these is the center tap for the... One of these is HD center tap, one of these is heater center tap. I've not done those tests yet, but it fairly simple to disconnect each one, figure out which role it's playing on the secondaries, and put it back. I'm showing this because I did an awful lot of work cleaning this area up and cleaning all these connections, and the chassis was really deformed here around the voltage selector. I took the voltage selector out, took all this out, and clamped this entire area of the chassis back flat so the bulges are gone. And I cleaned and I cleaned and I cleaned. I put everything back together, and a little bit of red nail polish to help things not vibrate loose over time. And it's going to be wired so the hot's going to go here to the inmost point of the fuse, and from there to the switch, and the neutral will go to the switch, and that's all wired up. And I have everything ready to be good. And I've got the new very solid chassis connection point for the AC safety ground all ready for it. And when the app's done, no one will ever see this again. It's all going to be buttoned up, and no one will know that I took the time to do all this to such a high degree of whatever. Maybe I need therapy, but this pays better. As I removed each component to replace it, I took the time to clean that area of the board material itself and all the tags and everything, and got off all kinds of gunk and grease and grime over the decades. And when I'm done, it's going to look a lot more like 1965. And more importantly, it's going to sound a lot more like 1965. Once the parts arrive, we'll test that hypothesis. Until then, as always, thanks for watching.